So for the first couple examples, we're going to take a look at what happens when we're given a vertex and just have to graph the parent function at that vertex. So basically, this is the process. We draw the parent function, and the parent function is drawn by simply repeating what you learned earlier about how the absolute value works. The absolute value of 0 is 0, the absolute value of 1 is 1, the absolute value of 2 is 2, the absolute value of negative 1 is 1, the absolute value of negative 2 is 2. And then what you're going to do is you're going to take that graph, okay, and you're now going to draw that exact same graph as if 2, 2 were the point 0, 0, right? It moves the vertex. So take that parent function and simply graph it starting here, 2, 2, and then from 2, 2, graph 1, absolute value of 1 is 1, absolute value of negative 1 is 1, absolute value of 2 is 2, absolute value of negative 2 is 2, and that is the actual graph that we're trying to graph. It also wants us to now take this point and graph it in vertex form. So vertex form for the absolute value is f of x is equal to, and remember this would be h and this would be k, so it would be the absolute value of x minus h, close the absolute value, plus k. So for this next step here, all it wants me to do is say, okay, well that would make this function that I graphed here in blue, f of x, and I like to just get rid of the h and k and just leave the negative sign here, right? And then put a plus sign here, and then literally you're just dropping h and k in. So that would be a 2, and that would be a 2. And if you have a graphing utility, you could graph that right now and see that we graphed it right, or you could use Desmos. If you type it in, it'll look exactly like we did. All right, so let's take a look at the next one. The next one's vertex right here is 0, negative 3. And so what we want to do is we want to take the parent function of the quadratic, which is 0, 0, the square of 1 is 1, the square of negative 1 is negative 1. If I square negative 2, I get 4. And if I square 2, I get 4. And it wants me to graph this instead at this vertex. So to do that, I'm going to go to 0, negative 3. I'm then going to go from here, 1 squared is 1, negative 1 squared is 1. So it's really about distance from wherever you begin. The distance negative 1 if squared is 1. The distance negative 2 if squared is 4. The distance 2 squared is 4. And then I will draw my parabola at that location as opposed to at the origin. And so that function, if put in the vertex form, would be f of x is equal to a parentheses x, always a minus, and then I'm going to leave it, and I'm going to square here, and then put a plus, and then all I have to do is put in the h and the k. So all I have to do is just put a minus 3 here. So let me just shift this up, and we'll alter it. Okay, so here we go. So the actual function is going to look like this. It'll be f of x, and there's nothing to go inside this parentheses, so it would just be a parentheses with a square on the outside. Sometimes when people type it, they don't actually put the parentheses on there, but it is kind of secretly there even if they don't put it. And then we would put minus 3 because you don't want to put plus minus because plus minus is minus. All right, let's take a look at an example of this with the square root. Okay, so square root, same idea. We have a vertex here, and we're going to take this point, okay, starting with the square root graph, parent function, which is 0, 0, 1. The square root of 1 is 1. The square root of 2 is a decimal. Don't know what that is. Square root of 3, I don't know. The square root of 4 is 2. And I don't have any negatives, so there's my parent function. But now I'm going to graph that parent function at the point negative 1, 3. So negative 1, 3 is here. That will be like my new 0, 0. The distance 1 square rooted is 1. The distance from here, 1, 2, 3, 4, square rooted is 2. And the graph looks like half of a parabola. Okay, so in vertex form, right, we would have, our vertex form would have f of x is equal to the square root of x minus h plus k. However, as you can see, this is h, so if I put a negative into a negative, this will be positive and this will be k. So our actual graph that we graphed, if I wanted to type it into Desmos or a graphing utility of any kind, I would have f of x is equal to the square root of x plus h. And that's the reason that's so important to understand. A negative and a negative makes a positive in this graph. So when you see a positive in an actual function, the graph, sorry, that's supposed to be a 1. The graph will go left that value. So I got one step ahead of myself. The 3 obviously goes here. So this plus 1 does not move the graph forward, it moves it backwards. But the plus 3 does move it up. Okay, so the next one we're going to look at is the parent function of the cube. So the parent function of the cube, notice I had to go by 2s. Most math teachers, if you leave it blank, understand that you are going by 1s. Some teachers are a little bit more stickler with that, and you have to graph even by 1s. Do whatever your teacher asks. I'm okay with leaving it blank as 1s, but everything else must be labeled. So the cube of 0 is 0. The cube of -1 is -1. The cube of 1 is 1. -2 cubed is -8. And then 2 cubed is 8. So if I take this graph and I move this graph to 2, 0, I'm going to go, sorry, -2, 0. This is where my vertex is. Remember, vertex is at that point. And so what I'm going to do there is from here, -1 will be -1. 1 output will be 1. -2 will output 8. And sometimes you have to count. So 2, and then 2, 4, 6, 8. It'll be right there. And then from here I'll go 2, and then 2, 4, right there. So I think those are actually off. My apologies. So 2, and then 2, 4, 6, 8. There we go. And then 2, and then 2, 4, 6, 8. So there we go. There's our graph. And again, to graph this, some people can graph it in one smooth motion, but a lot of students, when they start off, draw a parabola going up and then a parabola going down. And make sure you count correctly there. I had to count twice to make sure I didn't make a little boo-boo myself. So to put this into vertex form, the vertex form, and as you're noticing, everything is staying the same other than how I draw this. So over here I had a square root, but over here I'm going to have a cube. So I have x minus h plus k. K is 0, so I won't put anything here. But again, h is negative, so a negative and a negative is going to make a positive. So down here, this will actually be plus 2. All right, so I'll have f of x is equal to x plus 2 cubed, and then you don't have to say plus 0, that would be the end of it. But again, notice that's a positive, but the graph actually moved left.